All right, welcome everybody to TGI Kubernetes. My name is Joe Beda and I'm a principal engineer here at VMware. I helped start the Kubernetes project about 5 years ago, started a company, Heptio, that was acquired by VMware. For those not familiar with it, TGI Kubernetes is a weekly-ish live stream that one of us does. I started it, but we also have folks like Duffy and Josh and others that Christian and Chris did it a long time for a long time that help do it. Also, we get together, pick a new technology in the Kubernetes world and play with it. And we all learn about that together. So that's the plan today. Do I sound okay? I know I look okay. I was at a customer this morning. I'm going out to dinner tonight, so I figured dress up a little bit. So, usually I'm not this formal for TGIK, but today I'm dressing up a bit. All right, cool. Yeah, YouTube is changing up a little bit of their live stream setup, and so I'm figuring stuff out. And so this is my first time using their new thing, but it seems to be working, which is good. All right, well, first, I like to say hello to everybody. I think one of the things that is humbling to me is that the TGIK audience really comes from all over, especially considering that it's 1 p.m. West Coast US time, which is like the worst time to be doing this because like every place else in the world, you all are like, done for the week and out drinking or sleeping or even it's tomorrow morning already. So thank you to everybody who's joining me from all over the place. Olav was here early from Copenhagen saying hello. Lamati is I don't think hardly ever misses one. Nice to see you. Martin from the Netherlands. Cedric is here. I'm going to be pointing out a blog post that Cedric wrote a while ago in a little bit. Shahar, Dimitri, Marcel, good to see you. Let's see. Yeah, Eric mentioned the KubeCon show floor. The episode that I'm doing today, I'm going to be talking about this templating language. Templating is kind of a configuration language called Q, C-U-E. And I did this live on the show floor at KubeCon. And so this is a little bit of a repeat of that. So that's the plan here. Let's see. Bogdan from Romania, Samir, Grigor, Tommy. Let's see. Alex from Paris, Robert, Yatin from Virginia. Oh, man. I can't go through everybody, but we have Johannes from Austria. I just love it. I love it. So good to see you all. And Philippe, I'm going to be mentioning your book. I'm going to be showing that too also. So thank you all for joining me. So today, let me go ahead and sort of like one of the things we do is I usually try and spend a little bit of time going over news of the week, interesting stuff happening in the world of Kubernetes, and sort of, a little bit of discussion thoughts on that. Hello to Portugal. And so let me go ahead and switch to this. Now, these things are all up in tgik.io/notes. I have that link posted in there. And this is a HackMD doc. And so if, as we go through the episode, if there's interesting time codes or other notes that you want to put in here, we can crowdsource this if you all like. Marco from Milan, good to see you. So the first thing I think, this last week, I was supposed to be there, but I'm just exhausted from travel, so I wasn't. This last week was reInvent, and there wasn't a ton of Kubernetes news except for some new EKS stuff, which is really interesting. I think the big one there is EKS with Fargate, and there's a blog post here on this. Essentially, Fargate is Amazon's ability to run containers in a native way. So this is essentially running Kubernetes without the concept of a node. And so the concept of that node disappears, and so the pods run natively on AWS. Now, what's really happening behind the covers is they're reusing, under the covers, they're reusing some of the technology that they built for Lambda, so that they're spinning up these micro VMs based on this technology they released a while ago called Firecracker, wiring those up to the network and finding ways to sort of use these lightweight VMs to squeeze a lot more in versus running full-size VMs. So really interesting stuff there. The one caveat to be aware of, and I think this is going to be true for anything in this class, is that these things are not conformant. Now, I don't know the individual limitations of Fargate. I haven't had a chance to play with it yet, but without the idea of a node, there's no idea of things like a daemon set, right? Because where do you run the daemon set? And a lot of times folks will install things on the node for doing security or monitoring or performance analysis. Your ability to do all that stuff goes away when you're using these things. Now, that being said, the management overhead of not having to worry about nodes is actually a pretty cool thing. And so it's really interesting to see Amazon coming out with that as an offering. And then the other enhancement to EKS that may have slipped under the radar here is managed node groups. And this was really interesting because when EKS first came out, the control plane was hosted, but it was left as an exercise to the user to launch and maintain the nodes for the cluster, right? So you'd start up a control plane, and then it was up to you to bring up nodes and attach those nodes to the cluster. Now what they're doing is they're supporting all of that automatically. And so they'll actually manage those node groups for you. That starts to look a heck of a lot more like something like GKE. And so this is a huge feature gap, both with Fargate and with the managed node groups that Amazon's closing here. So that's some interesting stuff there. Now, 2 weeks before that, the week before that was Thanksgiving here in the US. So I didn't get a lot done. And the week before that was KubeCon. There's a lot to unpack. KubeCon was overwhelming. So reInvent is obviously overwhelming. It's like 60-some thousand people in Vegas. But KubeCon was in San Diego this year, and it's a jam-packed week. There were almost 12,000 people there. What's fascinating is we're seeing the conference change a little bit. I think we find a lot of folks coming to KubeCon looking for solutions, and it feels very much like a vendor conference. But when you go to the keynotes, it's still very much focused on projects. And so I think as and then as those projects start to diversify, so that we're not just talking about Kubernetes, we're talking about a whole bunch of other projects. That's one of the things that's fueled the growth of the conference, fueled a lot of the excitement there, but I think has caused the conference to maybe fracture a little bit. I think different people are getting different experiences. So it's been interesting to watch it grow over time. Big announcements there is here at VMware, we announced this new project called Antrea. This is a networking solution, so CNI, sort of core networking solution based on OVS. OVS, Open vSwitch, very mature data plane for this type of thing, has a hardware abstraction mode for it, and is something that we have a ton of experience here at VMware. So the networking team is actually getting started with this. Still very early days. We want folks to play with it. The goal is for this to be something that is portable, widely usable, a really good starting point for anybody who wants to have solid networking for their cluster. So that's something to check out. We'll probably, me or Duffy will probably be doing an episode in Antrea at some point. Let's see. So George, there's the, this just starts playing. This is a pointer to the playlist for all the videos published out of KubeCon, and I think it says it says 200, but there's got to be 369 videos, which is absolutely crazy. But then what's really Cloud Yuga, these folks apparently do this for each KubeCon. George pointed me at this. Here's an index of all the different things with the direct links to the videos. And so if you want to get an idea of the different talks, catch up on them, see the slides, this is an awesome resource. So Philip's asking in the chat, how does Antrea interact with NSX? Well, there's I think we're still figuring that out. I think the idea here is that we definitely want to leverage the knowledge and the understanding that we have from NSXT with OVS and bring that to the Kubernetes world in a lightweight way. So when we talk about Antrea, we talk about it being Kubernetes native, in that the control plane is leverages Kubernetes and Kubernetes APIs. I think we're going to find ways such that when it's running on NSXT, it can take advantage of fast paths through hardware if available and provide visibility and security that stretches across these things. But we definitely want to build Antrea so that it is integratable with other underlay networking systems, so that it's not just a custom fit to NSXT, but there's a bunch of extensions where, for instance, one of the things I'd love to see is that when folks are running on EC2, you can get a lot more speed when you're doing an ENI type of situation, and that's like the built-in or the Amazon provided networking CNI implementation. But there's a limit to the number of IP addresses that you could get there. And so having something using OVS to actually sort of split the difference between those, having some pods sit on ENI, other pods use an overlay, and mixing those things together, I think that's going to be the type of things that will be interesting to see for extending Antrea. Still very, very early days, so still figuring out what it means. But I do have a sticker for it, so look at that. The team gave me a sticker, so that's at least something. But yeah, we'd love to get your thoughts on that. Okay, so another awesome thing is Carlesia has been working on this probably for over a year to get everything, and it was sort of it was a little bit like there were ups and downs, there were ins and outs, but a new podcast called The Podlets. And this is there's an interview format to go with it, and it's really a lot of it is taken from the point of view of newer users going back and doing a lot of 101 stuff. Nicholas, who's on here, was involved with it also. So happy to see this finally making its way out there. Carlesia is driving it, but there's quite the cast of characters getting involved here, including some names that you may recognize, and then there is, if you go to the podlets.io, you'll see this. And I believe there's videos to go with it too. And so I did an episode here with them, and you can see, oh yeah, there's my face. You don't want to see that. But really, really nicely done. The huge amount of work from Carlesia and Co to actually make that work. So very, very exciting. Let's see. Next thing I want to call out. This is really cool. So Philip did this stuff here where a bunch of work to essentially take the Kubernetes API, format it, generate PDFs, docbook, that type of thing. So this is Philippe Martin, who's on, right? Am I saying your name right? I hope I'm saying it right. From Paris did this. And then what's super cool is that he actually had one of the books printed and was super nice to send it to me. And so I have the copy here, and it's really, really cool to actually see this written out. And the formatting is actually really nice and readable. So super, super cool stuff. It's kind of crazy to see it written, in written sort of hard copy form. All right. So thank you for that. Let's see, Kubernetes 1.17 RC2 is out, making its way along. You can start looking at some of the changes that are coming along here. And obviously, most of the time when this is happening, there's usually, let's see if we can dig in a little bit, there's the draft change log that folks are, this may not be here, maybe some. Yeah, so so you can start seeing, okay, oh, this is all the stuff. You can start seeing all the changes that are coming here. So a lot of interesting stuff coming there. I don't have a good feel in terms of the top line things coming with 1.17. I think, as we get closer, I'm going to be digging in and wrap my head around everything that's coming. Let's see. So I haven't looked at this yet. Here's a R operator. George pulled these things together. I haven't seen this yet. This is cool. So this is a ROperator. This is a Rust-based operator writer. So this looks really, really fun. Something that I want to dig into. I've never programmed in Rust. Maybe I should, use this as an excuse to start learning. Lamatti is asking, what are my thoughts on Jesse and Brian's formation of Oxide? Do you think that there's a market for this? Seen the space firsthand at Google, so I wanted to get your thoughts. So for those not familiar, Jesse Frizzell, Brian Cantrell started this startup that they call the Oxide Computer Company. Their goal is to generate essentially new data center hardware and kit along with an integrated software system. At least that's what I understand from it. It's a very bold play. It's a big, ambitious goal that they're going after. There's a lot of great experience. They're super smart people. They got a long road ahead of them. So I think, they're still very much at the beginning of their journey, and I'm looking forward to seeing where they're going. So that's my take on that. I was going to put that here, but it's not really Kubernetes related. But I'm excited for them to see what they do with it. So very, very cool. Let's see. Here's a blog post on how T-Mobile uses Kubernetes, which is really cool. Goes into a lot of the details. They move some pretty millions of transactions. What is the number here? 1 million plus transactions per second through their stuff. Super, super cool to actually see that. This is they're doing a lot of stuff with PKS, which is VMware's enterprise Kubernetes offering. And then finally, another one with how Pinterest uses Kubernetes, and this is really interesting. Reading through this, they've gone through and actually done things like generated their own sort of services, jobs, cron jobs, daemons, training jobs, all the stuff. They've essentially created their own CRDs for a bunch of these things, which is really, really cool. And that really shows the power of the extensibility of Kubernetes. If you're like, hey, you know what, I don't like, the way that services work, I'm going to actually do my own version of service, you're perfectly free to go off and do that. So that's actually really, really cool. And then as you see that, one of the things they'll do is they'll take this and then they'll expand this out into something that's more fully fledged. And so the interesting thing, this includes like a deployment and stuff. The interesting thing in my mind here is that this is another way in some ways to actually skin the cat around configuration management. You can do that resolution of some higher level thing down into the sort of granular stuff. You can do that outside and then submit the granular stuff to Kubernetes, or you can do that live inside the cluster with things like these, like what Pinterest did here. And so that duality of actually having it be a preprocessor step versus something that happens in cluster is something that I think we're going to see develop over time. And it's another way to skin that configuration cat. All right, so that's the pre-prepared things that I wanted to go through. Went a little bit long there, but I want to jump into Q now if you all are ready. In terms of putting Q in context, there's Cedric, who's on the line here, put together this blog post that I think does a good job of laying out some of the challenges here. And I think that, and we've talked about other systems in this vein, YTT, JSONet, KSONet that we did earlier, Kustomize. And so the first thing to recognize is that I think we've all done this journey where you start with some simple YAML, and then you're like, well, I just need to change this one thing. And so maybe you edit by hand, or maybe like you use some combination of make and awk and set and M4 to be able to do text replacements, Golang templates, that type of thing. And I think pretty early on you find that sort of text-based interpolation really runs out of steam and is super, super painful to author. And I think that the greatest example of this is Helm chart templates. The templating system in Helm is, I think Helm succeeds despite the templating system, not because of it. I don't think anybody's in love with using Golang templates for things like Helm. I think it's just honestly a matter of history mostly at this point. The next level is like data layering with Kustomize. What's interesting to Kustomize is I think as we've seen Kustomize continue to grow, what we found is that sort of data layering of sort of merging and patching is still super useful when you need to do arbitrary changes to some sort of template. But I also think that it runs out of steam because we're seeing more and more sort of specialized mutators be built into Kustomize. And so we've moved from templating to, write an extension and go ship it with your thing, execute it there, which ends up starting to blur the lines between that and something like a YTT that uses Starlark, which is a Python derivative. And so the next step that Cedric defines here is a data configuration language. And this is something that is Turing complete, built for essentially dealing with large amounts of configuration that needs to be validated, schematized, specialized. And so the previous thinking on this is that these things sort of go in a loop where people say, hey, I'm going to use YAML as a simple format. I'm going to write code to do it. Okay, now it does just do it in code. Oh my God, that I'm writing code to do everything. I thought this was supposed to be simple. Let me create a higher level YAML to do it. And then that cycle sort of starts all over again. And so that's the traditional way that this stuff actually goes. And I think we're finding that folks are like, hey, let's see if we can split the difference. Let's see if we can do something that starts off feeling simple, but then those sort of coding features are brought on as necessary. And I think that's when we look at these DCLs and data layering techniques where we're still experimenting in that space. I haven't given up yet. I think the other way of actually sort of attacking this, and I don't think I would add a fourth category here, which is, configuration generated from general purpose languages. And so I think that's when you're using something like JavaScript or Python or whatever to actually generate not some sort of specialized language, but you're using a general purpose language to generate your config. And I think something like Pulumi would be an example of that. So very cool. There's a lot to go here, but this actually does an intro of Q. What makes Q special, the sort of types versus values thing. That's what we're going to be going into a lot today. And there's a great tutorial in Q around Kubernetes, and we're going to start digging into that also. Okay, so if you go to qlang.org, stands for Configure, Unify, Execute. I think this is, again, domain-based naming. My guess is that Marcel got the domain, so this is the name. But basically, it's in the style of a programming language where there's a set of directory, there's files, you run a command on that. That command takes input, puts output. This does not talk to Kubernetes directly. It's still left up to you to actually take the resultant YAML and find a way. Oh, the name came first. Okay, so I'm wrong. Q just without the CUE was taken. All right. But I think the interesting thing, and I think this is what we've seen is as people have broken these things down, separating out the configuration language from the workflow for how you apply this is an interesting sort of evolution that we're seeing here. I think similar to this would be like YTT, JSON, those things are all sort of sit outside of the application domain. And I think we're also finding that this configuration problem, well, I think is best known in Kubernetes world. It's not the only thing that uses YAML, and I think we're going to see more and more systems in this vein, whether they're Kubernetes based or not. The YTT stuff came out of a lot of experience in the Bosch world, which also has a lot of YAML to be able to configure. And so there's a lot in common across these things. And then Marcel, who wrote this, his history is building a similar system that sort of grew organically a little bit inside of Google called GCL, Google Config Language or General Config Language, I forget which it is. So a lot of lessons from there being applied here also. So if you start digging into the documentation, good place to start here is there's a tutorial and tours down here is interesting because this actually goes into sort of like a talk of the language. But then also there's integrations here which talk about, hey, you can generate JSON, YAML, and knows how to actually derive a schema from Go. We'll get into that details. Protobuf, OpenAPI and CRDs, and then raw knowing how to determine things from Kubernetes. Okay, so it's the general configuration language at Google, but it's only available inside of Google. So it's GCL for Google. But it's interesting that these things, and I think this is one of the things that we're seeing is that there's technologies that are incubated, understood inside of Google. Or companies like Google. I think that Facebook is also throwing off interesting technologies, and they sort of grow up inside of that organization, work well there. But as they find their way to the outside world, there's lessons that are learned that can be applied, but then also there's requirements and realities in the outside world that don't necessarily apply within Google also. And so these second systems like Q, like Kubernetes, like I think, an example would be Scuba with Facebook, with Honeycomb doing that as a startup, are interesting points where it's like essentially people taking these ideas, mixing them with the real world, and then new things kind of come out. Yeah, so GCL is a generalized form of BCL, which was the config language that was built for Borg. One of the interesting differences, I think, between BCL and Kubernetes and the Borg ecosystem is that BCL generated a set of configs, but there was still a lot of sort of handwritten code to be able to apply that to a Borg instance. The Borg API was not as regular as the Kubernetes API, and it didn't sort of have the Kubernetes, it doesn't have the Kubernetes resource model. So a lot of the extensibility and controller patterns that we see with Kubernetes actually don't exist in Borg at all, which I think is a really interesting thing. And so that meant that BCL was actually pretty specialized for Borg, whereas GCL was like, hey, you want to create a proto? We can create a proto for you. Correct me if I'm wrong, Marcel. I think that's the way that I remember this stuff coming. All right, so let's start digging into what Q is. There is this very computer science-y talk about the logic of Q. And the logic here is not like logic in terms of, it's more like, language logic. So if you're a language nerd, which I'm not, and I kind of wish I was, I don't have the grounding there, this is actually a great place to start. But I think a lot of folks will do better by actually dealing with the tutorial here that actually goes through sort of some of the concepts with Q. And so the first thing to recognize is that Q, when you're using it in its simplest form, looks a lot like a friendly JSON. And so here's a Q file called json.q, and you can go through and easily export this, and it'll just come out as JSON. And so you can see a lot of the niceties here, like you don't have to quote all the keys. You can leave the commas off. You can have commas at the end. You can have comments in it. All the things that when you're hand authoring JSON you wish you had, Q has those things out of the gate. And so let's go ahead and actually just sort of try this out just to show that, hey, this works. Now, the one thing I forgot to do is I'm running a slightly old version of Q. It says version custom. We're going to install the latest version of Q here. Oh, it's on brew now. Look at that. Which Q? This is, I have it sitting in, okay, so RM, which Q? We're going to go and do that. We're going to go through and do this. Yeah, it's a lot easier now to install it if you're using Homebrew. Very cool. All right, so Q version, which Q? Oh, I have to do, was it hash? I always forget. I think it's -R. Does a reset. There we go, 0.15. All right, cool. Cool. All right. So, all right. So now we got it installed. Let's go back. So I think, like I said, so let's try and actually sort of do this, and we'll actually see. We'll play around with this and see how this works. Touch test.q code test.q. Now, one of the challenges for creating a new language from scratch is that. Oh wait, what's going on? Man, every time I start visuals, I thought I already did this. Is that you need to do language modes, you need to do syntax highlighting, GitHub doesn't know how to render it. So that's, so Q is still relatively new, so I don't think any of those language modes in Visual Studio and VS Code are actually for this Q. They might be for something different. But we can go ahead and we can type that. We're not going to get language highlighting, unfortunately. Oh, there's a Vim version for it. Okay, cool. Now we can do Q export test.q, and you can see now it exported the JSON. And I bet you, oh, so this is probably a different queue. Is this a different queue? Q sheet. Oh, Q sheet. Ah, do you remember Q sheets? So Q sheets were this thing for when you have a long audio file, when you like rip a CD. It's a thing that actually gives you the track lists and stuff. So Joel says that there's a VS Code extension. Do you know what it's called, Joel? What do I got to do to... No, I don't see it. It's not in the... All right, well, we'll dig into that later. It says restart. I just restarted it. Oh, it's not in the marketplace yet. Okay. Okay, so there we go. So that's how it goes. Now, I think similarly... Okay, let's see if this thing... There is probably a way to export YAML, right? Q export... Yeah, out... YAML... test.q. Boom. And then... what does text look like? Oh, it's like you can't do that because it doesn't resolve to a string. So if you're able to actually sort of resolve it all to a string, you're actually there. Okay. So you have to install the VS Code extension manually. All right, we're not going to do that. It's too easy to get sidetracked. Okay. So the key thing about Q, and this is like, it sort of bakes your noodle a little bit, is that types and values are actually part of the same sort of hierarchy. And so what happens is that you can take two things and merge them, and they can merge as long as they actually are congruent with each other. And so you can take something like a schema here, which says I have a municipality. It has a name, a population, a capital, a string, an int, and a bool. And then I can merge that with my data here of like Moscow. And because this is of type string, it sort of derives from string, I'm good to go. Because this population, 11.92 million, is a type of int, I'm good to go. Similarly, true is a type of bool. But it's not as simple as a type hierarchy. You can actually generate different types of constraints. So you could actually go through, and well, let's play with this a little bit here. And this is what some of this stuff actually sort of gets into. We'll go through and we'll say municipality there, and then we'll have Moscow here. And I believe, and then we can say Moscow is of type municipality. I believe this is how it works. And now if I export this, value string. Municipality.name. What am I doing wrong here? Do I have to put... Cannot convert incomplete value string to JSON. Oh, I see. I think, is there a way to say, I think if you do the double colon here that says that, don't bother exporting that, okay? There we go, boom. So, so essentially what we're saying here is that now if I say, hey, capital is a string also. Now what we're going to say here is, you have true and string. You're trying to merge these things across these two different lines 4 and 9. So 4 and 9. And true is not a type of string, so we can't go ahead and do that. So we can undo that. But then you can also do name is or int. Right, so I can do name as a string or an int. So now Moscow works, but I can also go and do 42 here. And that'll work because we can essentially construct these constraints. And the 42 is compatible with string and int. And these things are actually order independent also, I believe. And so, we can specify things like that. And it doesn't matter, same old thing. So that is like when we start talking about in Q, and can you all see this? Let me make it a little bit bigger, sorry. When we all sort of, so it's a little bit like TypeScript in some ways, but the interesting thing is that you can carry these things through. So you can both provide defaults and specializations in the same hierarchy. And so now this also applies in a way that's sort of similar in some ways to customize, where directory structure actually gets pulled together. And we're going to get into that as we start going through the Kubernetes examples. But the idea is that generally at the root of your hierarchy, you're going to have a bunch of schema. In the subdirectories, you might have some policy that starts to specialize things. And then the leaves, you'll actually have the fully qualified things that you're dealing with. And so the way that things work inside of a module is that it actually loads things, it loads the queue files up the directory hierarchy to be able to create this sort of inherited system as you get up, as you get more specific in your directory structure, you get more specific in terms of your schema and your policy to the point where it gets fully qualified. And that's a really interesting way. And then there's tools to do automatic refactoring with this stuff, which is really, really fun also. Okay, so that is that idea there. If fields are duplicate, that's fine. They'll merge as long as they're the same value. And oh, we have duplicates here. So this is an example of this. Okay, and so this is similar to that city thing that I did, where you can have a schema, you can have this, and then, oh, and then there's another thing here where if you do, instead of export, if you do eval, it actually gives you the output, but it sort of cleans it up and resolves everything. So that's pretty cool too. And that's essentially, and so, oh, and then the final thing is that you can go through and you can do, so we can combine these things together, and I can say it's a municipality and it's this, and that anding essentially joins those things together. So that's sort of a shorter way of actually doing this. Carlicia, how's it going? Good to see you. So same sort of thing going on there with that. So that's a way to sort of bring those things together. And if you look at this, and if you know JSON, and I like, this is a little bit like the combination sort of operator in JSON. But the one thing here is that this is still order independent here. And so that means that, this can actually sort of like, it can specialize, but it doesn't override. And I think in BCL, GCL, and JSON, the thing on the right of that sort of join thing can actually override. So if I actually have this be, I don't know, is there a historic different name for Moscow? I'm sure there was, because every Russian city was named three times. But let's call it, New York, right? If I go ahead and do that, that's going to give me an error because we're actually conflicting New York and Moscow. And so this thing is not an override. It's a join, assuming that you can actually take these, that these things are mergeable, that they're actually part of the same hierarchy. And there's sort of like fancy computer language sort of, things in that sort of logic of queue thing. So I'm not using the right terms, but this is the intuitive sense that you can get free of here. So the idea here is that, some of these things, oh, and then finally the last thing I can do is I can have something here being like cool, or like num tacos, so Moscow, I'm going to say has 10 taco shops, right? So this is actually part of my schema, but now it actually in some ways becomes like a default here. And you can actually do something like we can do number or 10, which now says, okay, is that? Oh, there's like a, what is the default? Oh, I can do that, and then I can put a star there, I believe is the, yeah. Oh, wait, no. It was it before? There we go. Yeah, the star. And so this ends up being like, hey, I can do this constraint. I have a default of 10, but number. So now I can go through and I can do num tacos. But I could also have, instead of 10 here, I could have my default could be no tacos, right? And so my number of tacos could be 10. Or if I sort of take this off, now it's no tacos as a string, right? So you can have these sort of sentinel values in there also. So this is very useful as we're dealing with some of the sort of idiosyncrasies of Kubernetes YAML. Things like ports can be ints or a port name. So it's an int or string type of thing can actually be surfaced here in a native way. All right, so that is sort of the basics here. There's a lot more going on here. I don't want to try and go through all this. I think the thing that I want to go through next which is kind of fun, and this is off the notes here, is this Kubernetes tutorial. And this is a whole sort of refactoring flow. We're not going to get through all of this, but we can get through a lot of it, which I think is really, really interesting. So the first thing that we're going to do here is if we go into the queue, I synced it from GitHub. This is under, let's see, where is it? It's tutorial. All right, are we back? Maybe. There we go. All right, sorry about that. Yeah, I think, something with OBS and the new YouTube streaming stuff, this stuff is always a little bit flaky. I think we're good now. Okay. Oh, Martin says no. Are we back, Martin, for you? Other folks say back. Okay. So what I did is I pulled out of the, okay, cool. I pulled out of the Q GitHub repo a sample set of Kubernetes sort of microservice-y things and then pulled that into a temporary directory. We'll start VS Code with it. And apparently, okay. And so what we have here is we have a whole bunch of directories that are services. We have front end, which has this bartender thing. And we see this pattern where we have a Kubernetes service object. We have a Kubernetes deployment object. And then and this is pretty typical that you'll always have, am I 8-bit? Is something wrong? You'll always have sort of a service and a deployment sort of paired up together. You'll have a standard set of labels and stuff. And there's just a ton of repetition in the YAML going on here. And I think this is one of the frustrations where it's like writing this thing once for a simple service, not a big deal, makes a ton of sense, feels a little verbose. Once you have, and I don't even know how many we have here, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15-ish of these things, let's say, something like that. I don't know. All of a sudden, this starts to feel a little bit oppressive, having to copy and paste stuff all the time. Now, Marcel tells me that this is an anonymized version of a larger service as an example. And so now the other interesting thing is that we're probably not going to deploy this today. We're just going to be using this to sort of manipulate YAML. And then you can use something like CAP, which is part of the K14S tool set to be able to deploy these things, or you can use kubectl apply or what have you. All right, so, oh, there we go. Okay, cool. So going through the tutorial here, the first thing that we're going to do is we're going to call qmod init. And what this does is it creates a directory here called q.mod. Now this is with things like this module.q and stuff like that. This thing is in some way similar to your .git file, where it provides a lot of context for the sort of Q installation. I believe you want to check this in with the rest of your configuration into source control. So that's the idea there. And then, so there we go. And now what we can do is we can go into services and do Q import. And things like the //..., that's obviously a convention borrowed from Go. And then we must specify a package name. And so we're just going to call this -pcube. Okay. List flag or files flag needed. Okay, so now what this is telling me is it's like, hey, wait a second. I'm trying to import stuff, but the way that's what's causing some confusion here is that I have multiple documents. And so Q doesn't know how to import multiple documents in natively because it generates a single document But right now we're importing a bunch of YAML, so we need a way to actually say, okay, here's how we actually map this stuff in. And so the way that you do this, and this is, a little bit tricky when you're sort of trying to do it automatically, is we're going to run this command here. And so this says, I want to import everything, and the package name is a Q concept of a package. And then I want to go through and take the kind and the meta and the name, and I want to use that to actually create a map for each of the things that I'm importing. And so what you'll see is we run this, and this will actually go through and generate, we'll take the bartender thing, it'll generate a cube.q file that sits buddy next to the YAML file. And so the cube.q file ends up being the sort of translation, the sort of conversion of that YAML file to Q. And what you can see here is that instead of actually having the sort of dash between objects that we have here, what we have is we actually have this thing, service bartender, which means that, so, okay, by default, just like, in JSON, you got to have that sort of that overarching braces. You can leave those out in Q. And this says create a service, under the service create bartender, and under that put this essentially JSON in there. So if we go through, and let's go through and we'll go to front end bartender, and we'll do q export cube.q. What this does is this gives us JSON, and that's essentially the equivalent of the YAML that actually came in. Marcel says that this will get much easier with some planned features, but for now, this is what it is. And then if we go YAML, is it the -t? No, q export, it's out. Okay. Oh, I have to give it to you. If we look at this, this ends up being, if you ignore these things, this ends up essentially being the exact same as the YAML that we started with. So that's a relatively straightforward way to actually bring these things together. And then let's see. So we can go through and do tree. And you can see that, okay, for each of these things, we're good to go. There's some other places where we have config maps and stuff, and we'll get to some of that stuff in a little bit. That's pretty cool. Okay, so it has us looking at Mon, Prometheus. Okay, so now this is the first cool feature, is that Q has built-in helpers to be able to encode and decode into YAML, along with JSON and other things too. So if we look at, so one of the things, if you've ever, and the reason why I did this is that Q is used for the Istio configuration, and Istio is really good at doing this like pattern here, but we also see it in places like Prometheus here. So Prometheus has, let's see, which one are we supposed to be looking at? The config map.q. This is a little bit big. What we see here is at some point, wait, let me make sure. Package cube alert rules. Okay, so, okay, yeah. So when we're looking at, oh, this is the YAML. If we look at the queue, what we see here is that alert rules, it uses this triple tick here, which is similar to like sort of Python quoting. It says that everything under here, and it'd be easier if we had syntax highlighting for Q, but this is just plain old strings, right? So I can go through and make this be invalid YAML, and Q has no idea about it, right? So like we're just passing strings through. And so one of the things that complicates when you're doing things like Prometheus, where you have, say, YAML inside of a config map that's included in another thing, is that you end up with this inability. You have these blocks, huge blocks of strings that are not being sort of imported into your configuration system. And so one of the things that can happen here is that if you actually give a -r, it tries to auto-detect when a string looks like valid JSON or YAML and automatically do some magic to be able to deal with that. So let's go through and we'll run our import command again. and we'll give it a dash cap R on it. And now when we look at this, if this all goes as planned, wait, did that not work? Oh, I need to go into services maybe? What did I do wrong? Oh, do I have to do it from that directory? Am I in the wrong directory? Oh, which? Oh, I'm modified. Let me, don't save. There we go. Okay, cool. Okay. Sorry about that. That was all me. So what we have here is that, okay, so he's importing sort of the YAML encoding package and giving it a unique name here. So this is just a hash just to make sure it doesn't conflict with anything else. I don't think 656E63 means anything. But now what we can do is we can have a hidden structure here called QAlertRules. The underscore right now means that, hey, this won't be output later. And I think Marcel says that he's working on an alternative way to actually do that. And then you can take that value and you can marshal it. And this says convert that structure into a YAML string. And so now we get all the features of Q, but those things can actually be used to help define the alert rules in a structured way. And so this is really interesting to me because it's not just one level of config, it's actually going multiple levels deep and actually dealing with YAML inside of a config map that's inside of YAML, which is pretty cool stuff. Okay, so that's that feature. All right, so now what we can do here is if we go and we run, are we supposed to be in the services directory? Which directory are we supposed to be in here? Yeah. Okay, so now if we run this thing here, this grabs a snapshot of our output here. Okay, what does the -c do? Q eval help. Does that concrete require the evaluation to be concrete? That means you can't leave anything saying, hey, this should be a string. It has to actually be the thing that it's supposed to be. And so this actually goes through and evaluates all the different files in this directory, all the different, and merges those into a single document, which is really, really interesting. So that's super cool. And we're going to use that as a baseline as we do some refactoring to see what changes over time. Okay. So, all right. So the next thing we're going to do is we're going to create, so we're going to take one of our files and we're going to copy it into our root. Okay. So we're taking this thing. So now we have this thing called cube.q. And what we're going to be doing is, I don't know why we copy it when we're like going to be modifying it, but we're going to essentially be replacing it with this stuff here. And so we could go through and sort of edit this down, but I think instead we're going to be saying through. So now this is establishing a schema, what we expect of all of our sub objects. And it's also establishing some defaults. And so those defaults will let us simplify and use some of the refactoring tools built into Q. But basically what this says is that everything under service, no matter what it is, we're going to take what it is and assign it to a temporary variable called ID. And then we're going to say, well, the name of the service and the name of the app label, those things have to be the same as what's going on up here. So those things all have to line up. It's automatically going to be in the prod domain. And the component, we're not saying what it is. It varies by directory, but it has to be a string. Right, so that everything in here has to be a string. And then finally, what this ... here is saying is that we can have multiple of these things here of ports, and the ports have an integer TCP or UDP defaulting to TCP, and then a name is either the string client or it can be some other string. And then we're saying that the selector for the spec on the service is the same as the label. So this is one of those things where all the labels across all your stuff just line up, which is probably going to be the 90-95% case. Similar type of thing happening here for deployment. Start with the default number of replicas to be 1, but it can be any integer. And then the template has a container where the name of the container lines up with the ID across all of these things. So now, this is a great place to start. So now what we can do is we can go through and eval, and we're going to get an error. And so what we're going to, the reason why we're going to get an error is because I didn't get an error. Why did I not get an error? Oh, I didn't save this. There we go. So now we got a bunch of errors. And what these errors are telling us is that we started to saying, hey, we have to have the schema. These things must actually line up. And we actually found some places where they didn't line up. And so one example here would be, and this is something that I think was an issue that, that Marcel was going to actually start looking into, is that this actually tells me the file, but it doesn't actually tell me the real directory that it actually is dealing with here. So we missed a lot of some of the context for debugging here. But what we can look at is Service Alert Manager metadata labels component. So I think that that's probably under Alert Manager here, kube.q metadata labels component. We don't have a component label here. But you can see here we said you must have a component label that's of type string. But here we don't. And so now what we've said is, just even starting out, we've said every service, every deployment in our entire hierarchy must have a label on it called component. We're not saying what that is, but it must exist. We found the places where it doesn't exist. So we're already actually specifying policy and finding bugs in our configuration where we didn't have one of these things. And so now we can go through and we can start using some of the capabilities here to be able to do some stuff. So let's see. So we can go through and we're going to go through and we're going to actually change our schema here such that where we say this component has to be a string, we're going to say it has to be component. Okay? And we're going to do the same thing here. So we're introducing essentially a new type coming on here. And then we're saying component is of type string. All right, so this is essentially, we're creating a new sort of type def in this language. Not exactly, I'm not the language nerd here. And now what we're actually doing is, and there's some voodoo here. I'll explain sort of what's going on here. Let me make sure I know exactly what's happening here before we do this. Okay. All right, so what this is doing is it's saying list each of the directories under services, feed that to sed, where sed is actually going through and removing blank lines. Feed that to xarg, where the interpolation thing is called dir, execute this shell command where we cd into the directory, and we're going to create a Q file under that thing that essentially just has the directory as the component, specializes it per directory, and then cd back out. So let's go ahead and run this, and I'll show you what this does. So now what this does is, this is some voodoo magic here going on for, but if we look under services, let's look under front end. We now have this new file called kube.q, and this says the component for this directory is front end. Similarly, down here for infra, or no, which is the monitoring one, we have one that says the, not for alert manager here. The component here is mon. Okay, so that's great. So now, and then the other thing we can do is we can go through is run format on these things, which is like go format, which is really cool too. Make sure that these things look neat. Okay, so now we'll actually go through and try and evaluate this again. And we can go ahead and diff. And we can see that there's places where the domain prod got added, right? And there's other places where we added a component also. And some of these may be like white space changes and stuff. But that gives you an idea of the types of things that we can look at as a diff. Okay, now the interesting thing here is that there's places where, if we look at front end, this thing says component is front end, but then when we actually dig into Q, this says that component is front end also. So we actually say, so Marcel says working on a native diff. Okay. So what we've seen here is that there's duplication now, right? Because we actually specified the component in the root directory and then the intermediate root directory, and we're also specifying it on every single thing. Same thing with domain prod. So there's a lot of sort of repetition going on here. But okay, so but we're still happy with this, so we're going to actually sort of like make this be our new baseline snapshot. So now we can actually call qtrim. So okay, so we're going to see if our stuff sort of lines up here. What this says is that we have 18, like almost 1900 lines of config. We can call qtrim and then do this again, and we're down to 1322. I didn't get the exact same numbers here, so this is a little out of date, but that's okay. So now what trim did is this is a refactoring thing. It says, hey, if a value is nothing more than restating of one of the defaults, just go ahead and actually trim that out. And so what we find here is now our service just has the port specified. All the labels, all that stuff is just using the defaults that are specified both here in component as front end, but then also in the top level schema file here. And so the only input into the services is the ID plus the actual ports that were specified, which is really, really cool. So we've already actually seen a significant simplification in terms of the amount of boilerplate that we have going on. But you can take, so this is part of that iterative process of finding commonalities across your configs, extracting those commonalities into these schema/default files, and then turning the crank and using qtrim to be able to go through and trim this stuff down. Okay, so now, and then we can actually form that nothing changed. Save that into a snapshot and do a diff. And, oh man, it said something changed, but didn't. Did I screw up some of my renames and stuff? All right, what changed here? I must have screwed up one of the renames or copies, so I'm not going to sweat that. Okay, but I think we're good. Okay, so now we're going to do better. And so at the top level template, we're going to actually go through and add some stuff to it. And this is going to be expanding this to other types of objects. So we'll go through. We're going to add a bunch of stuff at the end here. All right, so now what we're saying here is a daemon set is this generic _spec object along with the API version, the kind, and setting the name equal to that ID. Super easy there. Similar with stateful set deployment, but we're going to actually say that, well, the deployment has a default number of replicas. This is one of the niceties of Q over something like YAML or JSON, is that you can essentially nest these things a little bit and save yourself some lines. Config map, same sort of thing here, but we're setting the component label there also. And then spec is something with a name that's a string, metadata that's the same as name, component, the label there. Config map is not actually taking spec because it actually doesn't have a spec. It's not a sort of pod-like template. And then same sort of things here that we're doing for domain component. So we're essentially sort of extracting a bunch of this stuff out and making it clear. Now, one of the other things that, let's see, Q format, so we can go ahead and do that. And then, so that's actually pretty cool. So we haven't removed the old definition of deployment, so there's a little bit of duplicate there. We can actually go through and unify those things. It says left is an exercise to the reader, so let's actually go through and do this. So we're going to say a service is not, well, so spec has a template. So this thing doesn't have a template, so a service is not going to be it, but deployment actually has a template. And so we can do, oh, what did I do? go through and don't save. Okay. Let me, oh, because I ran Q format and it confused it. Okay. Sorry. Wait, that's bartender queue. That's not what I want. Sorry, I'm confusing myself here. All right, so we got that stuff there. Okay, so what I think we can do is we can do deployment spec and this. We can do the eval. That works fine. We can do Q trim. Does that work? Okay, and then if we look at this, oh, I would have expected that. Oh, maybe trim only works across directories, that type of thing. Okay, but let's look at deployment. We have spec, replicas, all that stuff. Containers name, app component. So this stuff looks like we don't need, okay, we don't need any of this at all. It looks like this is a duplicate here. So I think we're actually good to be able to delete that. So that's the type of thing that we can do. Okay. And then, yeah. So, okay. So we got that going on. And then, now this is where things get a little bit more interesting. And to be honest, I'm not sure I fully grok what's actually going on here, but let's try and actually decode what's happening here. So now what we're actually saying here is that we're going to have this new type called spec, which is essentially the sort of port stuff. And we're going to say that if something actually conforms to this, then it has true or false as an export on ports defaulting to true. And then we're going to go through for each of the deployments, daemon set and stateful sets. We're going to go through and actually define a new thing, which is service, which is the name of these particular things inside of these things. And then for a value, we're going to pull out the labels. We're going to, oh, and we're going to create a new service out of deployment, daemon set, and stateful set. So this is actually really interesting. What we're saying is that for every single one of these, we want to create a buddy service. And that's going to share the labels from the original deployment, daemon set, or stateful set. And it's going to go through and specify ports on the service as long as those ports don't have _ export false on them. So this means it will automatically export every port from a deployment, daemon set, or stateful set, regardless, doesn't matter. We're going to go ahead and do that unless there's this special tag on those things saying, please don't export me. So this is like, there's like this scripting thing, which now, instead of actually just being purely declarative, there's a way to actually sort of introduce some logic here, which really gets interesting. And there were some features in BCL that were used to essentially take something and explode it out into sort of a N by M sort of tree type of thing for doing things like serving trees with web search and stuff. And so this starts to get at some of those features. Okay, so talking about a lot of the stuff going on here, this is not something that we're going to actually dig into yet. And then we're going to go through, we're going to do some quick patches here where we don't want to export some of these things. So we're going to set some, so for infra events, infra tasks, and infra watcher, we don't want to export any of the ports. So we'll set that, we'll change the default for those things. We'll go through and do that. Wait. Okay, yeah, we have to do this. Oh, wait, where did I lost what I was doing. Where'd it go? Oh, there we go, okay. Okay, so now, let's see how many lines we have now. So we'll do, oops. All right, so we have 1358 lines. Now we're going to do trim again. And we're down to 1231. So we've actually lost quite a few lines. And what we ended up losing was, if we go back here, I don't have service anymore in this bartender file. So we've gone from this where I have to specify both the service and deployment, but we've actually said, hey, for every deployment, also create a service. And all the information we need for the service is encoded here because we have this container port thing that automatically knows to be able to expose all of that. So that's pretty darn cool to be able to actually do that. And then, but we have another trick up our sleeve. There's a simplify option that you can send to trim or format, and that collapses structs when you can actually go ahead and do that. If we look at bread dispatcher, we can do the trim-s. And now you'll see things like metadata annotations. These things are now sort of collapsed in. So it sort of, saves you a bunch of the new line BS that you have to deal with. All right, and then finally, we can go through and start having some other defaults that we're going to actually put in our directory. So like if we look at front end, we're going to say everything under front end has this Prometheus scrape annotation, right? So that's a lot of boilerplate that we're actually seeing across this stuff. And some of them we're missing. So like this one has the port that it should scrape, and this one just says scrape equals true, but forgets to actually list the port. So what we're going to do is we're going to come in to the Q file at that root of the front end, and we're going to say, well, every deployment needs these two annotations, and the container port is 7080 unless you specify something different. But here we're actually saying, well, actually instead of repeating that thing, just index into the first port and assume that that's the one that you want to scrape off of. So that's actually pretty cool. So we can go ahead and do that. We'll do Q format. And let's make sure we don't have any errors. And so now if we do, wait, what was our thing for getting? Okay, and so now, so that's a val. We didn't format. We got to do a trim. So now we can do a trim there. And now we're down to a little over 1,000 lines. And so now what we can see here is if we go back to this bartender file, holy moly, we're down to like nothing but the container image. Everything else, because we're using defaults, because we're using all this templating, everything else actually just sort of disappears and is shared across everything in the front end directory, specifying this. And then the standards for that are then specified across everything here. So there's like a lot of boilerplate's been removed as we've gone through. And then we can do similar stuff. Like if we look in the kitchen, we can actually see like dishwasher. This thing still has a bunch of stuff here, including things like liveness probes and stuff like that. And so we can, if you know this well, so that one's like debug health. We have a standard across all of our things in this component. We can go through and actually add that to the kitchen q.cube, right? Where scrape is true. Our first container has a container port of 8080 and a liveness probe. We're now off to the races. And now I can do a trim on the kitchen one. And now we're down under 1,950. So this is pretty cool that we can actually find all this commonality here. Now if we look at dishwasher queue, there's still a lot here, but you can see like, oh, maybe I want to have a standard config map mapped into all my services. That's the type of thing that you can actually go ahead and put into that boilerplate. All right, and then same thing here with disks. Okay, so this is actually kind of cool. So we can go through and we're going to go through and do this, and we're going to say, okay, we're going to have a hidden thing called has disks, And if it has disks, we're going to go through and assume that we have a disk based on the name of the deployment. And then there's some GCE, so let's assume this is GCE. We have a persistent disk of type ext4, similar with secrets and stuff like that. And then mounting these into the containers. And I don't understand the full context of the ... here. Does this mean it gets merged with other stuff that's already there? I'm wondering, one of the things as I read this, Marcel, is there an idea of a merge key? Is that something that you've built in here to be able to actually deal with the fact that we have, it says that there may be more entries. Okay. So let's go, so we can go ahead and do that. And then we're going to do, for sous chef, we're going to actually go through and say sous chef doesn't have disks. So we can do that here. Merge key, not yet, but it's high on the list. Okay. For those who are not familiar, I can explain merge keys. Do you all know what I mean when I say merge keys here? So yeah, so the template definition is not ideal. The things are positional and stuff, but we still get a lot of efficiencies here. Okay, so now we're trimming. All right, and we're down to almost 900 now, right? So you can see how like you could chip away at this stuff. So that I think is this sort of the getting started here. One of the things. Okay, the one we're running out of time here, and I don't want to run things down too much. There's this way that you can extend queue with sort of it's like the CLI thing that you can start dumping stuff into YAML and encoding things. So this is a way to extend queue so that you can essentially, based on that structure, generate a bunch of YAML files. That's pretty cool. So you can create the service bartender, bread dispatcher, blah, blah, blah. Very cool stuff there. So it's not, what I like about this is this looks like you're writing kind of Go to some degree, but this is all actually using Q to extend Q, which I think is pretty darn cool. And there are places where you're essentially exec running where you can actually shell out on these things. But a lot of the stuff can be done without leaving Q. And then the last thing that I think is really interesting here is we can, and I already have Go, I already have Kubernetes downloaded. Or actually, no, I don't have the API stuff downloaded, I don't think. So we can do a go get here to make sure that this, so one of the integrations that Q has is the ability to understand the way in Kubernetes we encode schemas in Kubernetes definitions and Go definitions. It's able to actually take those things, understand what's going on, and generate schema for them, which is actually pretty darn cool. And if I'm downloading this, hopefully this will actually download somewhat fast. Let's see what's going on here. There we go. Okay. So now we can go through and Q get Go. This saying, hey, go in that Go package, extract out the type definitions, convert those into Q. And so now we'll go through. And this stuff then, we're doing this for apps and core. And now if we go and, remember I said we had this Q mod? There's Gen here, which is actually API machinery, where here is essentially a schema that's all generated, and there's some advanced sort of stuff going on here. Like, what does the at go mean? I don't know. So there's some advanced stuff here, but the idea here is that schemas can be written by hand, like what we did in that example, but they can also actually be extracted from other sources, whether that be a proto-def, whether that be Go source code, or whether that be things like because that's to allow mapping back to Go in the proto-buff. Okay, so it provides for a two-way mapping there. So now if we go ahead and do that, and then it says, okay, what we can do is we can intermodule we can go through and create this thing called Kate's defs. Right? And so what this is actually saying here is that I'm now insisting, let's see, where'd it go? Okay, now what this is saying is that I'm importing core v1 and apps v1 as two of the schemas from Kubernetes, and I'm insisting that all my services conform to the schema imported from the Go code. Same thing with deployments, daemon sets, and stateful sets. And so now, and we can go ahead and format everything. So now what we can do is, if we do an eval, it took a little bit longer to eval because it actually doing that. But now what we've actually done is we've confirmed that what we've generated are true Kubernetes objects, that they're actually not surprising us in some ways. And so if we go through here and let's actually violate this in some way, where I'm going to go here and I'm going to create a new, on my spec, I'm going to create a new metadata label, which is foo123. Now, one of the things that you'll often do, this is a mistake that I make all the time, is I'll actually be specifying a label or an annotation. Those things are actually specified as string to string. But in YAML, sometimes you want to put a number in there and you forget to actually put the quotes around it. And so this helps you catch that because it actually said, oh, look, services, bartender, spec, selector, foo, conflicting values 1, 2, 3, and string. It says 1, 2, 3 is not a type of string. This string actually comes from the generated schema from the actual Go code. And so this is actually, and this is, I think, that the interesting sort of take that Kube brings all together is that it's fundamentally focused on creating not just reducing boilerplate, but also creating things that we know are going to be compliant with a particular schema. And so that schema awareness is a really, really, really interesting property of Q that I really like. And so, yeah, so now I can go through and I'm like, oh, I made a mistake. Let me go through and do 1, 2, 3. Now, look at that, boom, no problem. So it actually helped me find that way before I tried to apply this to my Kubernetes cluster. And so these things can be generated, but then you can augment them with your own constraints. Where you say, hey, Kubernetes is crazy. I want to actually lock things down even more. You can go ahead and do that. So I think with that, I think there's more here. I haven't made it through all of this. There's more you can do. But I think this definitely, for me, gives me a real flavor of how Q can work and how can it work not just for a small set of configuration, but for a large set of configuration as you start looking for ways to find commonality, reduce boilerplate. And so the fascinating thing is that, like, when you take a look at customize, what you end up with is bases that you modify. And when you take a look at Q, you end up with instantiations where you actually extract commonality. And so it's really a matter of templating in different directions versus, extracting commonality. And that commonality can both be on the schema level, but also on the sort of default level is a different problem from essentially taking a configuration and then specializing it. So it's sort of it's in some ways it's an anti-customize, and so from that point of view, because it's actually looking at this from the other direction. So with that, I'm going to call this good. Hopefully this gave you all a little bit of a taste of what Q is, why it's interesting, some of the unique things that it does. I think it takes a little bit to wrap your head around it in terms of some of the things that are going on. The sort of types equals values is very powerful, but I think it also is something that makes it be a little bit of a higher learning curve. I think for when we look at configuration languages, part of the challenge here is that we want the simple things to still feel simple, and we want people to be able to ease their way into using these configuration languages. And so I think Q is doing a decent job of sort of surfing that edge with providing abilities to import things. And then as you actually go through and start extracting the boilerplate, it's not totally alien looking. You can start to reason about it. So when I look at, like, something like this cube.q that I end up with. Let's look at sort of the top level one. Did I lose that? I don't know. Where did it go? Cube.q. Is this the top level? Yeah, this is the top level one. I kind of can sort of intuit what's going on here, where I'm saying a service, where there's a star here. I see these things lining up. It doesn't feel as alien as some of the other sort of configure languages as you actually start pulling this stuff out. And so I do like that. I think you do start to get into some questions when you're reading this stuff without actually sort of totally wrapping your head around it. Like, what does the sort of the double colon mean? One of the things that I think would be super useful for Q, and Marcel, here's a suggestion for you. This was something that was built over time inside of Google for BCL and GCL, is that there was actually a web tool that would actually show you the fully final rendered version of your stuff. But then you could actually go through and say, hey, where did this value come from? Right? I said, like, I see this value, I see this, and be able to actually trace back sort of like, oh, this thing ended up being 37. Oh, that 37 was specified here and here and here, and it was actually, these are the constraints. So essentially a way to sort of visualize the source of where things actually came from. I'm sorry, I did that thing again where it's like I didn't switch back to my screen when I was actually talking about stuff. But I was looking at the Q thing here and saying that as I look at this is not totally crazy in terms of stuff. But I do see like these types of constructs will look alien from the outside, the double colon. There's another thing that we didn't get to, which is question colon, which means that it's an optional value. So those types of things. So I'm thinking maybe a tool that that helps you see the final rendered form, but then start to introspect where things are. I think another interesting tool would be to find factorization possibilities. Like, hey, everything in this directory looks very similar. Do you want me to actually do this thing? Or even it's like, hey, everything in this directory looks the same except this thing looks like you might have forgotten some stuff. So in some ways, when you're Excel, when you do like a fill and it's like you do 1, 2, 3, 4, 5, and then you accidentally repeat 2 times, Excel will actually put a thing there saying, hey, this looks out of order. I expected to see these things lining up, but they're not lining up. Having some tools that would help you refactor and drive this sort of refactoring loop might be really interesting also. So, so those are some interesting ideas, but I think what Q has right now is super, super interesting. I'd love to see, it'd be interesting in my mind to explore what this would look like as we start, like we talked about earlier, that thing that Pinterest did, where they're essentially creating their own operators to be able to take things and actually specialize them. And I'm wondering, like, what would it look like to make a Kubernetes operator out of Q? Where you could use Q as the main programming language behind your operator for doing this type of translation. And, can we use annotations to be able to relate stuff back? What happens when you have errors? So I think that would be really an interesting thing to explore. And I think, as we look at making operators easier to write in general, leveraging stuff like Q is part of it. It reminds me in some ways of, a little bit of Googleism here, is that the way that MapReduce worked inside of Google, and my understanding is they're not using MapReduce anymore, but the way that MapReduce works inside of Google is that you would start up one job on Borg, and then that job would start up all the workers that it needed to do, run the MapReduce, and then shut down those workers. And so in some ways, MapReduce inside of Borg was very much in the operator pattern. It didn't have a CRD. It actually had its own config that was created when you launched a thing. But it was this idea you launch something that launches other things. And what happened is BCL ended up being embedded into the MapReduce controller, sort of that seed process that you started, and got evaluated at runtime. But it was always a little bit messy in terms of being able to do that stuff. But I think we already see these echoes of controllers in the way that MapReduce worked at Google, and this idea of like, hey, I don't want to be talking raw Borg API from within my controller. I want to be using a higher levels tool set like Q to be able to do that. I think we're going to see that pattern repeat as we look to create controllers. So that's actually, I think, pretty exciting too. All right, well, that's it. Thank you, everybody, for joining me. It's 2:30. We've been going for about an hour and a half. I'm excited about Q. I think that there's a lot of great ideas there. In terms of like next week, I'm going to be meeting with a customer, so I'm not going to be able to do TGIK. We're at 98. I think we were going to try and save 100 until after the new year and try and do something a little bit special there. Maybe pull a bunch of folks together and see if we can get a big Zoom going and sort of reflect on TGIK at episode 100. I think that'd be a lot of fun. So if I don't see you all before that, I hope you all have a great new year and keep on enjoying Kubernetes. And thanks for being a part of the community. All right, signing off. I'll see you all later.